Good morning, everyone. How are you? I hope you're doing great. This is your teacher Janice, and welcome to Math is Fun. Today, you are expected to illustrate the permutation of objects. Identify a situation that illustrates permutation. List possible arrangements of objects. And appreciate permutation as vital part of one's life. My friend is wondering how many ways she can arrange the 4 different white-potted plants in her terrace. These are the plants that you wanted to arrange. We have fish eye aglaonema, bird's nest fern, daisy, and aglaonema rotundum tiger. How many possible ways she can arrange these 4 potted plants in a row? Can you help her? Great! Come on, and let's find out. Let's have a game first. I'll make sure that this game will be simple and easy. And of course, you'll be having fun. And to make it more fun, invite the members of the family to join and play with us. Are you excited? That's good! Here is our game. Guessing a word. In this game, you are going to guess the correct words or phrases by rearranging the given jumbled letters. Very simple, right? You will be given 5 seconds to give the correct answer. Are you ready? Come on! Here is the first question. Oops! There's a clue. The clue is, this is a technique where the values or different possibilities are tabulated. You're right! The correct answer is making a table. Here is the second word. Hey! There's a clue! The clue is, it is a counting principle that involves a complete list of all possible outcomes. You are right! That is systematic listing. Number 3. The clue is a counting technique in which 2 events are independent, and 1 event occurs in A ways, and the other event occurs in B ways. Then, these 2 events occur in AB ways. The correct answer is fundamental counting principle. Number 4. Here is the clue. A technique uses line segment originating from an event to an outcome. You are right! The correct answer is tree diagram. Were you able to recall those given words and phrases? Excellent! These 4 are the counting principles in determining the different possibilities in an event. Come on, and let's find out permutation. Let us consider this situation. Erna invited her close friends Chona, Mary Grace, and Emily to her 18th birthday at CML Beach Resort in Nonong Castellamare. She prepared a special table with chairs placed in a row to be occupied by her 3 friends. Can you list down all possible seating arrangements?
That's right. Chona can be occupy the first chair, followed by Mary Grace and then Emily. Chona, followed by Emily and then Mary Grace. Mary Grace can be occupy the first chair, followed by Emily and then Chona. Mary Grace, then Chona, then Emily. Emily can occupy the first chair, then second is Chona, the third is Mary Grace. And Emily, followed by Mary Grace and Chona. How many possible ways they can be seated in a row? Yes, there are 6 ways they can be seated in a row.
Do you think order is important in the seating arrangement of these three friends? You are right. Order is important in seating arrangement. This is just the same when we are creating the password for our personal account. Order is important. So these two situations illustrate permutation. So what is permutation? You are right. Permutation is an arrangement of all or part of a set of an object with proper regard to order. We can determine the permutations by listing. We can also use table and systematic listing, as well as the fundamental counting principle. This fundamental counting principle can be used to calculate the total number of permutations. By then, we can assure that our listed possibilities of an event is correct.
Let's take a look at this example. Suppose you secure your bike using a combination lock. Later, you realize that you forgot the 4-digit code. You only remembered that the code contains the digits 1, 3, 4, and 7. List all the possible codes out of the given digits. Determine the number of permutations. To answer this problem, we can use any of the 4 counting techniques. Let us make use of systematic listing. This is the method used to determine the number of possibilities of event made for each problem. The advantage of this method is you can see all the possible arrangement of an object. Again, in the problem, we need to list all the possible outcomes, and there are 4-digit codes, which composed of 1, 3, 4, and 7. Using systematic listing, let us list first all the possible codes, starting with number 1. Let's say 1, 3, 4, 7, interchange 4 and 7, then we have 1, 3, 7, 4. We have 1, 4, 3, 7, interchange 3 and 7, then we have 1, 4, 7, 3. We have 1, 7, 3, 4, interchange again 3 and 4, then we have 1, 7, 4, 3. This time, let us list all the possible codes starting with number 3. 3, 1, 4, 7, interchange 4 and 7, then we have 3, 1, 7, 4, and we have 3, 4, 1, 7, interchange 1 and 7, we have 3, 4, 7, 1. Another 3, 7, 1, 4, interchange again 1 and 4, then we have 3, 7, 4, 1. This time, let us list all the possible codes starting with number 4. So we have 4, 1, 3, 7. Interchange 3 and 7. Then we have 4, 1, 7, 3. We also have 4, 3, 1, 7. Interchange 7 and 1. Then we have 4, 3, 7 and 1. Then we have 4, 7, 1 and 3. Interchange 1 and 3. Then we have 4, 7, 3 and 1. And lastly, list all the possible codes starting this time with number 7. So you have 7, 1, 3, 4. Then interchange 3 and 4, you have 7, 1, 4, 3. Followed by 7, 3, 1, 4. Interchange 1 and 4, you have 7, 3, 4, 1. Then we have 7, 4, 1, 3. Interchange again 1 and 3. Then lastly, we have 7, 4, 3, 1. So how many possible codes? By counting them, we have 24 codes. Let us make fundamental counting principle to check if our obtained answer is correct. Remember, fundamental counting principle states that if there are A ways of doing something and B ways of doing another thing, then there are A times B different ways to do the both. Back to the problem, there are 4-digit codes combination lock. These are 1, 3, 4, and 7. Then we are asked to find how many possible ways are there. So let us count the number of digits that can be placed in the first digit. All 4 digits can be placed in the first digit. So we have 4 choices. Let us say I place 1 in the first digit. Now, how many ways or choices can be placed in the second digit? Yes, there are 3 choices because 1 is already placed in the first digit. And suppose that 3 placed in the second digit, hence only 2 digits, say 4 and 7, can be placed in the third digit. So how many choices can be placed in the third digit? Yes, there are 2 choices. Let's say 4 placed in the third digit. Then only 7 can be placed in the fourth digit. So there is only 1 choice that can be placed in the fourth digit. To solve, they can place 4 digits. We can solve 4 times 3 times 2 times 1, that is equal to 24 ways. For the second example, there are 3 cyclists in a race. In how many ways will they be arranged as first and second placers? This time, let us use making a table. Remember, this is a technique where all values or different possibilities are tabulated. Meaning, we're going to create a table and place all the needed data. On the first column, you will write the number of events. Second column, the possible arrangement. And for the third column, the number of arrangement. In a given problem, there are 3 cyclists. Suppose these 3 cyclists are cyclist A, cyclist B, and cyclist C. For the second column, list down all the possible arrangements. For example, cyclist A for first, cyclist B as second, cyclist A and cyclist D, cyclist A and cyclist C as first and second respectively. Cyclist B and A, cyclist G and A, cyclist C and A. Take note, AB is different from BA. So there are 6 number of arrangement. Let us use fundamental counting principle to check if our obtained answer is correct. Remember, we need to find the arrangement of cyclists as first and second placer. How many cyclists to choose from for the first place? Yes, there are 3 choices. What about number of cyclists to choose from for the second place? Yes, there are only 2 choices for the second place since one cyclist being the first placer. Applying the fundamental counting principle, we will multiply 3 and 2. The answer is 6. So there are 6 possible arrangements.
The arrangement of the cyclist is in absolute order. That means the arrangement is important. That is an example of permutation of distinct object. And what is the permutation of distinct object? It refers to the different arrangement of distinct objects in a line, it is the different arrangement when no objects are identical or the same.
Permutation can be seen everywhere, like in this big pen. Can you see permutation in this big pen? You are right. Arranging 3 different pigs in the cages. What makes permutation distinct objects? That is, 3 different pigs are all distinct things and are arranged in a line. What makes permutation distinct object is that arranging 3 different pigs are all distinct things and arranged in a line. What about here? Can you see permutation in this place? Yes! Parking 3 different cars in the garage. 3 different cars are all distinct objects and arranged in a line. Now it's your turn. Let me see if you can identify if the given situation illustrates permutation. So let us have a short game. Are you familiar with the game? Fuck the fuck and bluff the bluff? Great! That's what we are going to do. You are going to identify if the given situation illustrates permutation, and if it is, then you are going to say fuck na fuck. And if it is not permutation, then you are going to say bluff na bluff. Now, are you ready? Good! Can you try that? Fuck na fuck, bluff na bluff. Great! Let the game begin. So here is the first question. Determining the top 3 winners in a mathematics quiz B. Is it a fact or a bluff? You are right. That is fact na fact. For the second question, choosing 5 groupmates for a mathematics project. Is it a fact or a bluff? You are right. That is bluff na bluff. Number 3. 3 people posing a picture. Is it a fact or a bluff? Yes, that is fact na fact. Number 4. Assigning 4 teachers to different grade levels. Is it a fact or a bluff? You are correct. That is fact na fact. Number 5. Picking 2 questions from a bowl. Is it a fact or a bluff? Yes, that is bluff the bluff. Going back to my friend's problem, how many possible ways she can arrange 4 different potted plants in a row? What do you think is the answer? You are right. There are 24 ways in arranging different plants. Can you list down one possible arrangement of plants?
Do you have this possible arrangement? Bird's nest fern, Aglonema rotundum tiger, and then daisy, and then fish-eye Aglonema. Very good!
Do you also love planting ornamental and flowery plants? That's great! So how will you help in taking care of these plants? Very good! Water them regularly and dig the soil.
And now it's your turn. Can you answer this problem? In how many ways can a coach assign the starting positions in a basketball game to 9 equally qualified men? Before that, let me give you information about basketball game. There are 5 starting positions in a basketball game. These are point guard, shooting guard, small forward, power forward, and center. And this is how they position in a basketball court. Can you name Philippine national basketball team? Right, Gilas Pilipinas. Are you proud of them? Of course. Now, try to solve the given problem. What is your answer? Very good. Using fundamental counting principle, there are 15,120 ways. Can you give one possible arrangement? You are right if you have this answer. First position, second position, third position, fourth position, and fifth position, you have man 1, man 2, man 3, man 4, or man 5. This is one possible arrangement out of 15,520 ways.
And now, can you give me one example of situation that illustrates permutation? You can show your answer in a creative, different way, like drama, video presentation, collage making, drawing, or even singing or poem writing, or any different way that you want to show your illustration of permutation. You can pass your answer during the retrieval of our module. You can also send the answer using your Google Classroom. And now we are about to end. So let us sum up the lesson. How can we illustrate if the given situation illustrates permutation? You are right. A situation illustrates permutation when the arrangement of the object is in definitive manner. The order of the arrangement is important. How can we illustrate permutation? Yes, there are 4 different ways to illustrate permutation. And these are making a table, systematic listing, fundamental counting principle, and tree diagram. Let me assess if you learned something in our lesson today. Kindly get a pen and a paper. You are going to write the correct answer for these 5 questions.
Question number 1. Which student illustrates permutation? A. Arrange 3 students in 6 different arrangements. B. Given 2 shirts and 3 pants, there are 5 different ways of matching it. Letter C. A coach chooses 3 swimmers among 5 winners. Letter D. Choosing 3 of your classmates to attend your party. And the correct answer is letter A. Arrange 3 students in 6 different arrangements. Number 2. The following involves permutation of distinct objects except A. Arranging 5 books in a shelf. B. Hanging 3 different photo frames in a row on a wall. C. Electing 5 classroom officers in a class of 45 students. Letter D. Picking 6 balls from a basket of 12 balls. The correct answer is letter D. Picking 6 balls from a basket of 12 balls. Number 3. Count how many different 3-digit numbers can be formed from the digits 1, 2, 3, and 4 if all digits are distinct. A. 5, B. 24, C. 60, and D. 120. The correct answer is letter B. 24. 4. Count how many ways can 10 students be seated in a row of 5 chairs. A. 360, B. 720, C. 30,240, D. 30,640. And the correct answer is letter C. 30,240. 5. Which situation illustrates permutation of distinct objects? A. Arranging 4 people in a row for picture taking. B. Putting 6 different plates in a row on the table. C. Awarding first, second, and third placers out of 10 runners of 100-meter dash competition. Letter D. All of the above. The correct answer is letter G. All of the above.
Oops! It's time to end. And for your additional assignment, in your journal, please write what you have learned and what you have realized in our lesson today. I hope you have learned something. Thank you for listening and see you again. Bye-bye.